Hello, everyone, and welcome to our latest webinar. We will start now as the time is ready to start. So thank you for joining us, and I hope you're fine wherever you are joining us from around the world. Before we start, just a few housekeeping rules as always. And of course, first I'll introduce myself. My name is Nele Kapp. I am working at UN Habitat as a solid waste management expert. And together with the Wuppertal Institute, we are bringing this webinar to you today. Before we start, as I said, please, just some rules. If you have any questions, and we hope you have some of them, put them in the Q&A box. So if you look in the side of on the control panel that you have, there is a questions box, and also indicate to whom your question is directed. If you have any general remarks or just want to say hello or where you're from, please use the chat for the same. Just to inform you, the webinar will be recorded and we will also share the slides afterwards on the NUA campus website, where you also registered for the webinar. Today's webinar is brought to you by the Wuppertal Institute for Environment, Climate, Energy and UN Habitat under the Urban Pathways Project, which is financed by the German Federal Ministry for the Environment under the International Climate Initiative. In the project, we cooperate with cities in the Global South to implement activities in the areas of sustainable mobility, energy, and waste management. The aim of the project is to contribute to the climate targets, the SDGs, and the new urban agenda. We also organize capacity building and exchange of good practices, because we believe that we can all learn a lot from each other. So today, this webinar is part of those activities, and we look at the bottommost part of the waste hierarchy: environmentally safe disposal. In the past webinars that we had as part of the series, we looked at how we can recycle or recover. And today we think that sanitary landfills are still like the backbone of every working waste management system. And therefore, we will hear about the Fukuoka method as one possible option. First, we will get an overview about the concept, and then we will learn more about its practical application in Bahir Dar, a city in Ethiopia. But before we start, we want to hear from you. And as always, we have some polls, but today they're just two very short ones. So the first one is there right now. So I'm kindly asking you to use your mouse and to click away. Which sector are you from? We just want to know who's listening in. So let us know if you're from a national or regional government, local government, an NGO, a private sector, or something else. So I'll give you some time to find your mouse and to answer. And then I will close and share the results. And here you go. We have no one. That's the first. No one from national or regional government. 20% local government, and then NGO, private sector a bit, and then most of you, over half of you, are from something else. Wow, this is a very unusual result for us. Thank you for letting us know. And then we have one other question. Very simple. We know that there's a lot of controversy about this topic, so we would like to know from you if you think a functioning solid waste management system needs a landfill. So yes, no, not sure. So this is just to find out what you think. If you think solid waste management needs a landfill or not. And then I will close and share the results with you. So 2/3 think yes, you need one. A fifth thinks no, you don't need anyone, and a few people are not sure what they should think about this topic. So thank you also for letting us know about that. And I think maybe today we will now, well, at least for those who think that it's an option, and maybe for the others who don't think so, we can discuss also later in the discussion about this topic. So now let me introduce our first speaker for today. His name is Toshikatsu Mito, and he's assisting solid waste challenges in African cities with the Japanese government, UN Habitat, and others. He also works in Japanese local economic development in the fields of wind energy and artificial intelligence. Mito started his work career at the Japanese Ministry of the Environment and later worked in Rwanda for several years. So Mito, we are happy to have you here. We can see you and we can see your screen. So I would say you have the floor, 20 minutes. Thank you very much. And we're looking forward to your presentation. We cannot hear you yet. You're muted. Let me unmute you. Now you're self-muted. Sorry, you have to unmute yourself again. Okay, now it should work.
Okay, can you hear me?
Yes, now we can hear you. Perfect.
Great. Thank you, Nelly, for the introduction, and hello, everyone. And thank you for this opportunity to talk about the Fukuoka method, one method for the landfill management. Speaking of the question posed by Nelly, my belief is that ultimately it's good to not to have the landfill for the solid waste management. It's not necessary. But at this moment, for many countries, especially developing countries, landfill management is still essential for at least for a certain time before establishment of the full recycling system or the full 3-year establishment. So let me make a brief explanation about what is Fukuoka method and how does it work. Then originally I wanted to show the video about the introduction of the Fukuoka method produced by the Fukuoka city, one of the developer of the method in Japan. But due to the technical problem, I can only share with you the image, not the sound. So let me try to communicate with the UN Habitat team and share the video later. But at this moment, I can show you the video and explain the contents. So please watch. So this video is produced by the Fukuoka method, Fukuoka city, one city in Japan, and it's the introductory video about how the Fukuoka method works. You know, like Japan is, you know, one of the advanced country, but still we requires a landfill. Of course, you know, recycling, reuse activities are promoted, but still some waste are still reaching the landfill. And the Fukuoka method itself was developed in 1970s when the Japan had rapid economic growth. During the time, the type of waste changed drastically, like increase of plastic and also the increase of the amount of waste itself. Then at the time, the national government requested the Fukuoka city and also Fukuoka University to develop the new technology to deal with the challenge at landfill. So before that, like the landfill was typical open dumping. It's just like waste was dumped openly without any treatment, which I think is very similar to many countries in Africa and other developing countries at this moment. So the situation was exactly the same. As you see now some pictures, these are the photos in 1960s and 70s in Fukuoka city. So I think you find a lot of similarities in your city's landfill, like a lot of fires, a lot of smells, a lot of flies. So the situation was exactly the same in Japan as well. Then during the time, the invention of the Fukuoka method was done. Then for this kind of open dumping landfill, the biggest issue was about how to treat organic waste. Organic waste without the oxygen, with a lot of accumulation of organic waste, methane gas is produced, which is explosive, very dangerous for the field workers, and also it can create methane gas, which is has a global warming potential, so it's bad for the climate change. So the Fukuoka method was developed to deal with that issue. As now you see the scenes, it's the situation, the anaerobic landfill situation, which is very common for the open dumping landfill. So a lot of organic waste is accumulated, then without oxygen, the decomposition happens in an anaerobic condition, then a lot of methane gas is produced. So countermeasure for this is this one, aerobic landfill treatment. This is the idea to using the electric fan and fill in the oxygen into the landfill body, which functions well to enhance the decomposition and reduce the generation of methane gas, but that is very costly. So it is not applicable for many countries, and actually it is not used in many cities at this moment. Then, as a combination, a kind of like in the middle ground, a semi-aerobic landfill management, which is called Fukuoka Method, was developed during 1970s. So the idea is to find a way to do the in-between, to enhance the aerobic situation without using a lot of money nor electricity. And it was developed by the Fukuoka city together with the Fukuoka University, one university located in the Fukuoka city. The key point of this landfill management system is big, the installation of the horizontal and vertical pipe with big diameter with some perforation. So usually, traditionally, the pipe was just used for the collecting the polluted water, which is called leachate. So it was only used for the leachate collection, but under the Fukuoka method, the pipe diameter is much bigger. So the upper part is used for aeration, not only about the leachate collection at the bottom part. Then usually inside the landfill body, due to the decomposition of organic matter, it can create a natural heat. So using that heat inside the pipe, natural aeration happens due to the updraft movement. So because of that, from the bottom part, as you see on the bottom, the air will be intaken into the landfill body naturally through this perforation. So this is the key point of the Fukuoka method. So no electricity, no extra energy was used, but due to this natural heat, decomposition heat inside the landfill body, updrift is created, and the movement of aeration, like aeration, is enhanced naturally. So this is why the system is called semi-aerobic. Then also this aeration function, the leachate around the pipe is also treated by microorganisms by activity is enhanced by oxygen. So the water leachate purification is also enhanced by this system. So both gas treatment and also leachate water treatment is promoted by this system naturally without causing the extra energy or extra cost. Then this shows that kind of effect for the how the semi-aerobic system is reducing the methane gas. And also this is the indication of the water purification. So the semi-aerobic system is very similar to the aerobic system for the water purification, and it's much better treatment than the anaerobic system. Then these pictures shows the introduction case in Fukuoka city of the system based on the Fukuoka method, and some key positive features are illustrated here. Then the idea and the technology is already exported to some countries, including some African countries as well. So it is the method is gradually expanded globally. Then as you saw some pictures, the idea is to use the locally available materials, such as bamboos or other things. Like sometimes metal materials, those kind of things are expensive or have a risk to be stolen. So we can think and find out a locally manageable material and use those materials. So there's a lot of flexibility for this application. Then this is the last topic about this video. So this is actually the area which was open dumping in the past. So the Fukuoka method was introduced into this site and stabilization was done. Then final closure was done, and now the site is used for soccer ground or schools, or like not the high-story building, but the low-story building, and also this is a gardening facility. So like a kind of like positive usage is possible because based on the Fukuoka method, the stabilization of the landfill body, the waste body is enhanced. So although it takes maybe 30 years or something, but still the stabilization speed is much quicker than the traditional open dumping management. So this is the landfill image of the current landfill in Japan based on the Fukuoka method. Okay, so for the sound of the video, I'll show you later together with the Habitat team. But as a summary, like just a recap, so this is the image illustrating the Fukuoka method. As I explained to you, the key point is the big pipe, both horizontally and vertically. Then idea is that using the natural decomposition of organic waste, the heat is created here, so the updraft of air movement happens. So because of that, from the bottom part of the pipe, natural air will be taken, then the oxygen will be brought into the landfill body. So the microorganism which can function by using the oxygen will be enhanced by that. So instead of creation of methane gas, the gas is converted to CO2, and also decomposition activity will be enhanced and promoted. And also around this pipe and this stone area, microorganism activity are further enhanced. So the polluted water coming from the landfill is purified around this pipe area. Then the final treatment will be done additionally at this end of pipe point. So here's the positive future list of the Fukuoka method. Low cost, easy maintenance, and also the idea is to promote the locally available materials, and also environment and health harms can be reduced by this introduction through the enhancement of biodegradation and also reduction of greenhouse gas emissions. The system is also recognized internationally. So under UNFCCC for the treatment of climate change, it is recognized as one methodology to reduce the methane gas and other greenhouse gases. And this is the picture in Kenya for the pilot site introduced for the Fukuoka method. Then as an example, which I involved for the activity, this is the one in capital city of Rwanda, Kigali city. So originally the site was typical open dump site, like waste without any treatment and a lot of fire on site. But after the introduction of the Fukuoka method, gas venting pipe was introduced, and the waste compaction and soil coverage was done. So the fire stopped and the scenery was improved, and also no like smell and flies, those are reduced significantly. But at this site, the introduction of Fukuoka method was done at the later part of the usage of the site. So the only vertical pipes were introduced, but still, like this system can enhance the decomposition of organic waste. So still positive effects for the reduction of methane gas and the purification of leachate did occur. Then this is as I showed in the previous slide, this is the image of the activity in Kiambu, Kenya. So originally the site was like this typical open dump site, relatively new site, so the amount of waste was not so big. So because of that, we not only installed the vertical pipe, but also horizontal pipe system was introduced. So this is the kind of like similar to the construction of brand new landfill place based on the Fukuoka method. So both vertical pipes and horizontal pipes were introduced. Another example is in Addis Ababa, Ethiopia, capital city of Ethiopia. So for this site, in March 2017, landslide, waste slide around this area happened, and a lot of people, more than 100 people, were buried by waste and killed. So after that, like we got the request for the intervention. So based on the Japanese fund or the UN Habitat intervention, we do the improvement of this site. So this is the image for the improvement activity. The rehabilitation activity is still ongoing, but most of the rehabilitation was done around this time. Then, as you show in the picture on the left, like gas venting and other facilities were introduced rather manually. So the idea is to use the local material and local manpower and create the ownership, local ownership, and keep the situation that sustainable and financially and technically feasible locally. Then this is a summary and overview of the Fukuoka method, but I like to show some key questions to understand the Fukuoka method better. Question 1. Can the Fukuoka method based landfill solve all the solid waste issues? No. As I said, the 3-hour activity, reduce, reuse, recycle, is essential. Without that, based on the Fukuoka method, we cannot reduce the amount of waste. So both activities should be done in parallel. The next question, should we use the Fukuoka method based landfill only after establishment end of the 3-hour? So do we need to wait for 3-hour establishment before using the Fukuoka method? The answer is no. Fukuoka method is effective even for the mixed waste. So even the waste is with a lot of organic waste, with plastic, Fukuoka method still can function. So my recommendation is that you can start introduction of Fukuoka method, then at the same time you can promote 3-hour activities. So the most important point is stop usage of open dumping system right away. Then next question. Can 3-hour be realized by promotion of waste segregation at the source? Partly yes, but it's not enough. Waste segregation is important, but most important point in my understanding is to find a market demand for the segregated recycled materials. Even if you separate the waste and you can recycle the material, if no one wants to buy those material, the system of 3-hour cannot be established. So you need marketing. You need to establish the market system to make the 3-hour system sustainable for the long term, which is rather difficult. So of course you can start the 3-hour promotion at this moment, and it's very important. But at the same time, you need to understand the 3-hour system establishment is rather difficult. So landfill usage is required at least for a while. This is my opinion. The next question is the landfill management maintenance free once the Fukuoka method is introduced. Sometimes this is like a big misunderstanding. Like once we visit the site and explain the Fukuoka method, the local experts understand that once the Fukuoka method landfill is established, that's over. Like all the treatment will be done automatically, but it is not true. We still need daily management. The minimum requirement is 1 bulldozer and 1 backhoe, and also we need a committed field staff for example, continuous installation and maintenance of gas venting system. That is necessary, and also daily instruction of the heavy machinery is necessary. So without having those machines and committed staff, we don't recommend to start introduction of Fukuoka method. Those commitment and machine preparation, those are the must. So once it's done, Fukuoka method can be introduced. Then the last question: don't we need a leachate treatment facility under the Fukuoka method? Yes, it's essential. But the level of leachate treatment has a quite diverse, and very sophisticated facility and treatment system is very expensive and very technically required and difficult to operate. It's not easy. So our recommendation is to introduce a step-by-step approach. As you see in the picture in the left down, this is the system called EcoFan, which our team invented. This is just using the wind, natural wind. Then this bucket, recycled the dustbin, can rotate and connect it to the iron pipe, iron bar, and the bottom part down the water, there is an electric fan. So this fan can rotate by natural wind and aeration can happen, so the organic matter inside the leachate can be purified and the decomposition is enhanced. This is the first step. Then gradually we can introduce mechanical and chemical treatment gradually, but the ultimate system is very, very expensive, so we cannot achieve that immediately. So step-by-step approach should be recommendable. So thank you very much. So this is from my side.
Thank you very much, Mitu, for this very interesting presentation. And just to say, I think it worked very well with the video, and it was even nicer to hear you speak than to listen to the video. So I think that was very well. We have some questions, but I would like to go to the second speaker and then come back for a final round of questions and answers after the second speaker. Great, so thank you. And let me introduce our second speaker of the day. Ms. Yewupsira Yeshiwas is the Solid Waste Removal and Reuse Group Leader in the Environment Protection, Sanitation and Beautification Office of the Bahir Dar City Administration. She holds a bachelor's degree in geography from Bahir Dar University and worked previously as geography teacher. We are very happy to have you with us. And we see the screen, we just need to see it in presentation mode. Great, perfect. And Yewupsira, you can start. Yes, we can hear you.
Okay, thank you very much. First of all, I am very happy for you give me your time. Next to that, I wanted to present with Bahir Dar Fukuoka Method of landfill. Landfill rehabilitation and Fukuoka model site construction in Ethiopia. Next to that, what in Bahir Dar, project title of Fukuoka Alternative and Sustainable Solid Waste Management in Ethiopia, implementation of the Fukuoka Method in Bahir Dar City National Pilot Project. Next to that, human resource management training and knowledge sharing. The first one full-time focal person assigned by the city for this project, while others represent productively visit our activity. The Fukuoka method starts from Bahir Dar landfill. I select the city for focal person. Next, the head of the city environment, sanitation, beautification of office cars, attendant EMO training in Fukuoka Japan. So 3 people, including the duty, may participate in the Africa clean cities or study to or landfill management. Next to that, one site training for experts and city officials. So sharing knowledge with students from Bahir Dar University. This project to succeed and next to that to continue time to time. Bahir Dar University students share or updated knowledge, so that some participants in survey and designing activities. Next, some has worked some papers on the Fukuoka method, solid waste management method, especially leachate volume estimation and leachate pond size determination. The second one, there is also interest to establish excellence for the Fukuoka solid waste management method in landfill or in Bahir Dar city. So the first project, sustainability, there is some problems in the direction of the project to succeed or introduce the landfill. The city owns the project or contribution follow up entities, day-to-day and monthly follow up the landfill systems of Fukuoka. Next to that, full-time focal person is assigned. Any direction of the focal person to introduce the Fukuoka method landfill presentative. Next, concerned city people, including officials, are trained on the concept and implementation of the Fukuoka method solid waste management. So there will be one site end of site operational training, machine operators, waste truck and drivers and city officials. This landfill of Fukuoka method to present operations of waste trucks and drivers and city officials coordinated them, and the process helped at the last end of the project of Fukuoka. Next to that, being a national pilot project, the project will remain on ISOF or MOD. Next, the nearby community is already enjoying the outcome contribute for its sustainability. The second one, project beneficial, the nearby community who suffered a lot from the poorly managed open dumping will benefit the most, and all residents of Bahar City and the surrounding community are beneficial. That means the landfill of site, there is some houses or any direction of people. So I disturb and continues this project, the Fukuoka method communities of behavior. Next, it will also benefit other cities in Ethiopia abroad with experience sharing of implementation of the Fukuoka solid waste management meeting. The third one, major outcomes expected. Solid waste will be disposed in a closed and controlled dumping area. At the first of Fukuoka method, starting this project, there is some problems of the landfill. Say, for example, dumping system of containers overloaded of dump. The odor of solid waste is very danger. After Fukuoka method project is solid waste will be disposed in closed and controlled dumping area. The next one, significant reduce methane gas production and fire. The fire of or the methane gas production is very high after the Fukuoka methods of project is lost, and the odors of the landfill is very dirty or very at any work of landfill treated. Next to that, significantly reduce pollution from leachate. Pollution of leachate solves a real problem of the nearby community, improving environmental safety and health. At the peoples of in Bahar Dar, environmental cities or safety is or health is very nice. Next, significantly reduce volume of landfill waste, decomposition and compaction. I look at the first of Fukuoka method project. There is so many problems of landfill. Solid waste project or dumping system of that very hard, and so that the Fukuoka method status of decomposition and composition part of landfill solid waste, it's nice or it's okay. Next to that, land use change of for other productive purpose and another purpose of any suitable of landfill. Another part, improved solid waste management. And so the landfill of the what we call in Bahar Dar of the project site, Bahar Dar to Addis Ababa, you can see the Sarsa level or the map system of health, map length of 320.74 kilometers, ground length is 26.82, heading of 153.14 degrees. Next to that, Bahar Dar landfill to distance of length 5.47 kilometers, ground length of 5.47, and heading 176.13 degrees. And then the landfill of the picture of that, as you seen, it's very sweet, or it's very at the road of landfill, and the little systems of landfill is as a picture to you and clear and understand. The designs of compilation extension figures as you seen, and it's the master sizes of a landfill systems of 0 up to 50 and 100 to 150 of master or the size of waste technology device of landfill. Next part, the design of the landfill of the leachate system of, as you seen clearly, grab or bed trail. Next part, before intervention of the landfill of the leachate system of the map or the figure, you can see and clear and the road of any direction of it and their parts or its safety, and there is no others, and like that it's a beauty and it's a nice landfill and the result of Fukuoka project. Next, before intervention, the Bahar Dar city of landfill, you can see the fire of landfill and the odors of landfill very high. After that, you can see after the picture of mapping. The site clearance, site of landfill, you can see as the project of November 2019, and the leachate system of any machines of directions, Fukuoka methods of continuous as a program of time, very rapid and continuous at a time of that. Next to that, site marking for embankment of construction work, you can see, and the leachate system of the focal persons and the any another persons of working in the landfill of the leachate system. Next to that, embankment of work is December 9, 2019. You can see, and the it's very leachate system of or banking system, embanking of system of that. It's a nice of the Fukuoka method of the result or the solution maker. Another to that, embankment of work, I mean direction of the fire systeming of it's very high. To control of that, it's very danger. But now there is no fire and there is no odor and there is no solid waste here and there, and what we call you see, and at the present of the time very sweet or very what we call Fukuoka methods of projects, very nice. Embankment of work, as you like to see in the pictures of embankment of work, it's very at the time of the program of any direction of the systems, suitable and on time is succeed. Another part of March 2020 embankment work and leachate collection pipe installation, collection pipe of installation part of landfills. There is at the project of at working of at this time. Leachate collection pipe installation, as you like, divided by 4 types of leachate, as you like. And my job is solid waste management group leader, ISO, and then I visited that part of leachate system. I'm very happy, and it's very nice project and so on. Next to that, installed the leachate collection pipes of the Bahardar City Landfill. It's a nice leachate system of waste, and installation of leachate collection pipe continue like mapping. Leachate collection pipe is covered with cobblestone and the gas benzene system. The collection part of or pipes of covered by, as you see, cobblestone covering of asphalt. So the benzene system installation is working for and hard workers, and so thank you, Mr. Mito, and another person of Dr. Brahanu, and focal person of Ms. Awada, and the another parts of the workers. Very so many problems. So the problems of that answer at a time to you, and finished the work of that and continuance of the work. Next, new access road construction. You see there is some problems of margins and continuance of at a time. Dr. Burhanuji is a hard worker. The problems of it comes another to send all the answers of the project. So it's up to June 2020. Then the newly construction access road is very nice road, and the tracks of solid waste collectors or another physics of the landfill enters the roads of Irregular. There is no any problems to enter into the landfill or outcomes of the landfill. The road is very nice and very straightforward. So that model site main and the branch pipes installation of these landfills of installation of the switch and the branch of pipes collected here and there as the mass of field. Another purpose of this project, leachate treatment ponds. As you've seen, the ponds of at the ground of landfill, it's continuous, systematically used by workers and systematically used by ponding system. Another purpose of the leachate pond connected to the gravel bed trench, and another any direction of sites of problem, it comes not the any systems of direction, the problems not stuck, immediate the answers of the problem solution of and so problems continue and the answers. The gravel bed trench is a few flows of the fluid waste of like this. After that, the kickoff of ceremony, and the Mr. Mito and Dr. Brahanu, as you like, and the pipe of the leachate of the workers and continent, and landfill is a very sweet for sea. After Fukuoka Method and before Fukuoka Method, the Bahardar landfill is very different between them. Now is very sweet and very continuous initiative to work back landfill site. So at the last, clean, green and beautiful Bahardar city by gifted natives, the lake of Tana and Abai, any direction of Bahar Dar city, very sweet, very clean, and so that as you give a time, give and invite Bahar Dar city. Thank you very much. Thank you.
Thank you, Yevusira, for this good presentation. Maybe while we wait for Mito to join us for the panel, already one first question. And also just to tell our audience, we have some time, so I will give you the opportunity to raise your hands and to then we will unmute you and you can directly answer questions. Maybe Yevusira, just one follow-up question. As you showed that the kickoff meeting was last year in 2020, right? So maybe you can just update what has happened in the past year with the landfill. Is it working to your expectations? Yeah, so maybe Yevusira, you could just quickly answer that before we go to the questions of the audience. Did you hear me?
Yeah.
Okay. Maybe you can just update what happened since the kickoff meeting.
Listening? Are you with me or Mito?
No, you.
Yeah. Okay. Thank you very much for asking me again.
What has happened? Like you showed us the construction of the landfill site. So I'm sure the audience is wondering what has happened in the past year. So since the kickoff meeting, is the landfill now operational? Is it working as you would wish it? Is it, you know?
Yeah. At the end of project, the Fukuoka methods of landfill contains types of landfill dumping site contains and the direction of the plan of solid waste deposit is continuous. At Mito, like the project of landfill Fukuoka methods contains at the start of any direction of solid waste trucks and any another parts of interfere that direction of landfill stops and systematically continues the landfill strategically end of continuous.
Okay, thank you very much. So let me go to our audience and to the questions we have. There are some questions, so get ready. So Pavan Mudu, you had a question, and I would give you the possibility, let me just find you in the list, to pose your questions directly to the audience. So you could unmute yourself and ask your questions directly to our panelists. Pawan Mudu, if you still want to ask your questions, now would be the time to unmute yourself in the okay, maybe you're a bit shy and you want to ask your question later. No problem. Then we will go to the next person, who is Kin Puyu Tandar. So Kin, if you want to ask your question, you can unmute yourself. Just click on the unmute button. You always have to, we can only unmute you, but yeah, perfect. Maybe say something. You should be able to talk now. Unfortunately, we don't hear anything. Okay, today we have lots of technical difficulties with the people joining. Usually it works quite well. Kin, you want to try again? Maybe if you can pose your question now. No. Okay, then maybe we can just, because you had so many questions, I don't know where to start with. Okay, let's first try the question from Pawan again. The question was, how does the Fukuoka method prevent landfills choking in water bodies or river outlets? So Mito, maybe that is a question you could answer somehow. Yeah, Mito, you can go.
Okay, can you hear me?
Yes.
So the question is about how to avoid the clogging of the water flow system by waste. Is that correct understanding, right?
Yeah, I'm also not very sure. So I understand the question how the landfills can contribute so also that they
Like,
themselves are not choking in water bodies or river outlets.
yeah, well, like a landfill contains a lot of things, like for example, plastic, those kind of things can clog the water flow system. There's a possibility. But under the Fukuoka method system, as you show the some image, around the pipe, there's a stone arrangement. Those stones are usually the function, one function of those stones to avoid the penetration of, for example, plastics to go into the pipe. So at the end of pipe point, like usually like those like big plastic or other big waste are already removed. It's not floating down to the leachate collection pond system. Then for others, like depending on the situation side by side, we need some to create some fencing or some filtration. Those kind of system are essential. But the big waste is already like there's a function under the Fukuoka method arrangement to let those waste to stay inside the landfill body system.
Okay, thank you so much, Mito. I hope that answered the question. If not, please just post again the question or we try to unmute you also later. So I'm trying once again to see if we can have someone talk directly to the speakers. So Brian McCarthy, you have a question to Yewopsira. So we have unmuted you. So maybe try to unmute yourself and just post your question directly to Yewopsira.
Can you hear me okay?
Yes, we do.
It was great to see Bahardar dump site transformed to the landfill. I visited it many years ago, or several years ago, before the plan for the semi-aerobic landfill was put in place. So it's fantastic to see it. Do you know how much the construction cost in total to do the transformation? First question. And then what machinery is now operating on the site, and what the experience of operating the machinery has been. Has it been quite reliable and with good compaction, or has there been challenges with the machinery? So first question is on the capital cost of constructing, and the second on experience of operating and what machinery you've utilized.
Thank you, Brian. Who wants to take that? Yewopsira, do you want to start responding?
Yeah.
Okay.
Okay, thank you very much. The project of Fukuoka Landfill in Bahardar at the last outcomes of money, I don't know the fact number, but the machineries, there is so many problems as he likes Miss Mito, and there is no machines by the projects of continents like that. At the time of the project activity speedily continues the machine of shortage. The money of at the last end of project, I don't know the fact, sorry.
Okay. Mito, you want to add something?
Yes, speaking of the cost, I don't know the exact cost from my side either, but around several $100,000 for the whole activities up to the current improvement. That is the figure I can say, the US dollars. Then about machine operation, as I explained in my presentation, about like at least one bulldozer and one excavator, or ideally one bulldozer and two excavators. Those are essential for daily operational management. Then speaking of the case of the Bahadar landfill, I also involved for that improvement. And there are 3 sections for the waste reception, and one section is already ready for the daily waste reception. But unfortunately, as Yashi was just mentioned, Ms. Yashi was just mentioned, like the city has a bit of problem about the procurement for the machine. It's still ongoing. So we are still waiting to receive the new waste inside that one because of that, you know, the shortage of the machine. So that is a bit of problem. Then for other sections, the finalization of the renovation still is ongoing.
Thank you, Mito. And I'm also seeing that one of my colleagues from UN Habitat in Ethiopia, Bahanu Kasa, was able to join. Bahanu, do you want to add anything on what Yewubsira and Mito said regarding the clarifications for Brian's question? You're muted. Yes?
Yes. And yes, good morning.
Seems like your connection is not very
I didn't capture all the questions. But
I think the main question over is how much is the cost so far of the landfill construction?
Okay. Exactly the budget allocated for this project is about yes, I think Mythos has said around 700. Of course, it can be 700, but the exact budget allocated initially was 600 around. But later on, there are some money which is pulled to the project because of remaining activities. So maybe 600 plus. Yes.
Great. Thank you so much, Bahanu, and thank you also for joining. Brian, do you have another question, or were all your questions answered?
Yeah, just another one from Mito. One of the risks, if the site is not operated properly with appropriate machinery, and the compaction is not so much, have you and the cover material is not applied, have you experienced a site like that where a fire has occurred because of the increased oxygen due to the semi-aerobic nature of the landfill? Is that my question is really, does the semi-aerobic landfill increase the risk of severe landfill fire in the case where the site is not operated correctly? We see throughout the world that the operation is more often than not the limiting factor long term in these landfills. We can do the capital engineering work, but then the operation fails. So just wondering if you've experienced where the landfill fire has been a higher risk due to the semi-aerobic nature.
May I answer?
Yeah.
Yeah, well, from my experience, you know, like once the Fukuoka method is introduced and the gas venting system was introduced, the level of methane gas generation is reduced significantly. Then after that, if the management is bad, like before having the methane gas issue, that the site becomes the open dumping site again. That is one concern. Then another point, like if the management is bad, you know, that proper management is not continued done even after the facility improvement, before having the methane gas issue, like rather like, for example, intentional fire by the waste pickers. That is very common. I experienced that in Rwanda. So like even though we did some intervention due to the procurement issue, machine mobilization delayed. So during the time, the site became the open dumping again. And also some intentional fire for the waste pickers to collect metals happened. Then we did the intervention again, something like back and forth again. So always the good improvement is necessary. Otherwise, even the method is quite recommendable, like we will see the open dumping site again. But for the methane gas generation, it takes a certain time. So like before having that issue, like other common issues will happen if the management is not done properly.
Maybe may I add some? Hello.
Sure, please go ahead.
Okay, good. I think Mito has captured the question, but as I understand, the question is fire is associated with oxygen. Yes. Yeah. The conventional method, in the conventional method landfill system, there is a high production of methane, and when methane comes into the surface, it came in contact with oxygen, a lot of oxygen. That is why fire break out at the opening of the methane gas at the surface of the landfill. In this case, a limited amount of oxygen is inserted, of course, piped into the internal landfill system so that aerobic bacteria can act or work properly, so that decomposition will be the result of aerobic bacteria instead of anaerobic bacteria, which result in the production of methane. Then in this case, with the free circulation of oxygen into the landfill system, internal part, then aerobic decomposition will take place. Then the resultant of that is the production of carbon dioxide and not of methane. Then the oxygen, even though it is injected into the landfill system for the aerobic bacteria to function well, that's not enough for ignition of fire inside the landfill system, because the amount of oxygen is limited inside the landfill system. Then fire break out only on the surface when the amount of oxygen is high or is great enough for igniting fire. So this the semi-aerobic landfill system, one of the main objectives of this system is to avoid fire, by decreasing the amount of methane produced inside the landfill as a result of the anaerobic bacteria. So this is against the argument raised by the I don't know the name, the one who raised the question. Thank you.
Great. Okay. Thank you so much, Berhanu and Mito and Yevusira. So going to the next question. Muguru David Ngige, you had a question. You have the possibility to unmute yourself and pose your question directly to our speakers. Let's see. If only Brian was today the lucky person to be able to communicate with our speakers. To unmute yourself, you have to go on the control panel and just click the microphone icon. Okay, unfortunately, we don't hear you, so I'll just pose this question. He's wondering if it can be used to manufacture organic fertilizer and bottling of methane gas. So maybe Mito, you want to take that as well?
First one I could understand. Second one,
Muguru is wondering if you can use the Fukuoka method to manufacture organic fertilizer and to bottle methane gas. Methane gas.
Oh,
yes.
Okay. So the key idea of the Fukuoka method, as just my colleague Berhanu mentioned, is the idea is to reduce the methane gas generation. So if we want to collect the methane gas as much as possible, this system, Fukuoka method, is not recommendable. Our system is to reduce the methane gas. So methane gas collection, if we seek on that, like a rather anaerobic system, is more recommendable. But then speaking on the first question, actually enhancement of decomposition is kind of the enhancement of creation of fertilizer. So if the idea of the landfill system based on the Fukuoka method is like a quick creation of organic fertilizer. So we can use the system even inside the landfill body, but if we can have the small system to separate organic waste and put that organic waste to the similar Fukuoka method system, we can create the fertilizer. So it's possible.
Great, thank you for that answer. I think it's just important to highlight that you said it's necessary to separate the organic waste before, right? So if you want to use it as organic fertilizer afterwards, you can use the Fukuoka method as kind of a composting, but you need to separate the organic waste from other waste before doing that.
As I said, even inside the landfill body, it's possible to make it decomposition. But the key point is, as I just mentioned, it's marketing. So if we do the decomposition together with plastic waste, we need a lot of separation work, which makes the compost more expensive, fertilizer more expensive. So we cannot sell that in a sustainable manner. So, separation from the source would be more realistic if we want to sell that fertilizer.
Great. Okay. Thank you so much. Then coming back to the questions that Kin Fiu Tandar had asked, there were many of them, so I'll try to merge them somehow. So coming back also maybe to you, Mito, you had mentioned that sometimes bamboo is used for as local material. So Kin is wondering in general, what kind of local materials can be used for the Fukuoka method, and then can bamboo withstand the leachate? And maybe also a question to Yewopsira, what material is currently used or is used for the leachate collection pipes in Bahir.
Okay, so maybe there are a lot of possibility for application for various materials, but what I know for the usage for the locally available material, like rather than the like typical concrete pipe or metal pipe, one is bamboo, as I mentioned, and then the other one is the discarded tire. We can use the discarded tire for even for the leachate collection or also gas venting system. We tried that in even Bahir and Addis Ababa as well, but those systems would be possible as well. And other wood can also maybe function for the leachate collection system as well. So it depends on the local context.
Great. Bahanui, do you want to add anything on the use of materials in Bahir Dar? We cannot hear you.
Sorry. For the collection of leachate, I think.
Yes.
I was muted, yeah.
Maybe also in general, what kind of materials were used?
In general.
Bahanu, we lost you, unfortunately.
Yes.
Maybe
different materials are used, of course. Not local materials are not applied in this project.
Are not applied. Okay.
Hello.
Yes, maybe you turn off your camera to improve the quality, so we can hear you at least. Sorry, we would like to see you, but yeah. So you said what we captured was that you that no local materials were used for the Bahir Dar.
Sure. Yes, let me tell you shortly what materials are used for this project. For the collection of leachate, a perforated pipe, concrete pipe is used, perforated, 2/3 perforated, that is used for the entrance of leachate and at the same time for circulation of oxygen in order to facilitate the aerobic digestion. And that is for the collection of leachate. And for the gas venting pipe, for the gas venting system, we used a metal drum, which is also perforated, and also a plastic pipe that's also perforated. Plastic pipe, usually erected at the center, and we have 3 perforated metal drums circulating or encircling the plastic pipe, so that is used for the venting of, for the entrance of oxygen and for the outgoing of carbon dioxide, and at the same time the remaining methane, which is produced as a result of both aerobic and anaerobic system. That is the second and third type. And then what we have used for the construction of the leachate treatment pond, we used an earth block. Of I think the size is around 2 centimeter times, no, 2 centimeter. Of course, it's 20 centimeter times 30 centimeter. I think that is the size that is used for the construction of the leachate treatment pond. Of course, that is coated with cement. That is, and then one more compartment of this project is the system which is used as a final treatment of leachate, that is the gravel bed trench. That's also constructed using the earth block, and of course is lined with cement and filled with gravel. That is for using as a final treatment for sludge.
Great, thank you, Berhanu, very much.
And then for the embankment, by the way, for the embankment, we use old waste. Totally old waste is used for the embankment, making.
Great, thank you so much.
Let me just... Sorry,
yeah, Mito?
Yeah, those materials are not true, like, for example, concrete leachate collection pipe and gas venting system. Those materials are not produced in Bahadar city, but it was produced in Addis Ababa by discussion with the local constructor, how to design and what is the best way in local standards. So we design and use the local material.
Great, okay, thank you so much. Maybe also to add on that, there's a question from Ahmed. If you can elaborate on the employment creation aspect of this method. Maybe Mito, you want to take that as well?
Well, the quick employment opportunity for the field work, our intention is to use the local people for the construction work. Like, we don't want to use the international company or like a sophisticated machine. Try to use the locally available equipment and the local labor as much as possible, like especially the waste picker. Like, once we mobilize those waste picker for the field work, they create the ownership. Then we can create the security, safety, and also the good management and daily, proper daily management together with the city staff. So that is the key essence for the activity. Then after that, maybe together with, like, as we discussed, for example, composting activity, and also as Berhanu mentioned, embankment is the old waste. So actually, this is the great compost site. So we sometimes recommend that the embankment can be used for the greenery activity, for planting vegetable or flowers. So maybe, like, in some countries, like that, those activities are recommended for the income generation for the ex-waste pickers. So that kind of things would be possible. Thank you.
Great, thank you so much. And looking at the time, I'll go to one, well, again, merge two more questions we have. There was the question from Solomon on the maximum loading rate suitable for the Fukuoka method. And also from Brian, which goes along in the same line. He's wondering, how deep can a Fukuoka landfill reasonably be? Can it be applied in large, that is deep city landfills? And related, has there been a case of combining semi-aerobic landfill with gas extraction, possibly flaring? And there's, like, if you know of any combination, I'm not going to read the rest of the question. So the first question, I think, is what's the typical loading? Like, how much waste can a Fukuoka method landfill receive, and also how deep can it be? And then we will probably wrap up.
May I answer? For the well, it depends. Of course, it depends on the area of the landfill. But basically, usually the typical landfill system based on the Fukuoka method is it's not the depth but the height, because we need to do the proper leachate correction by using the natural gravity. So we cannot dig down. We just add up and do the compaction of the received waste. Then the one level of waste is usually 3 meters high. Then up to, like, it can be like 5 something. It's quite possible, but like basic maybe starting point, 3-layer would be quite possible way. For example, in Baharda, we designed a 3-meter high, around 3-meter high, then 3 layers, so up to 10 meter, 9 meter of the waste reception is possible. Then we need to use the site as kind of stairs to avoid waste slide with 30 degrees. So that is the maximum capacity of reception. Then for the another question, like we cannot, as I said, the key point of Fukuoka method is to reduce the methane generation. So we cannot combine the Fukuoka method and the flaring. Like our idea is to, like omit the flaring process. So we can just convert the methane gas to CO2 as much as possible. So we don't generate the methane gas under this method. I think I answered all the questions by that, right?
Yes, I think so. Thank you very much. And unfortunately, we are already at the end of our session. So I would like to use the opportunity to thank our panelists, to thank Yiwopsuya Yeshiwas for her presentation on the case study of Bahir Dar, to Toshikatsu Mito, and also to my colleague Bahanu Kasa, who joined shortly to answer some questions. And maybe to sum it up, I mean, we've learned that, or we discussed today that at least in many countries, we still need landfills. And this should also be, Mito mentioned, he thinks this is one of the first steps to avoid open dumping. It's really important to go away from open dumping. And the Fukuoka method is a semi-aerobic landfill. It's one of the many possibilities of building a landfill. It's a low-cost methodology that can be used, that can use also locally available materials, as we heard. But it also has to go hand in hand with other options or other measures in the waste management system, including, and we always talk about the 5 R's. So we need to rethink, refuse, reduce, reuse, and recycle. And then this can all go hand in hand together. So thank you so much. Thank you everyone for joining and for your great participation for the many questions we've had. As we said, the presentation, we will share also the presentations on the NUA Campus website, as well as the recording. And now it's just left to me to wish you a great rest of the day, wherever you are. Take care and stay healthy. Thank you.
Thank you very much. Bye-bye.
Bye.
Thank you very much. Bye.